Hey, hello, welcome to the show. It's me, JP. It is time for JP's product pick of the week. Thanks so much for coming on by. We got people over in our various chats, and the key ones for you to check out, if you haven't, are YouTube and our Discord server. There are other places that we're broadcasting, but I can't keep eyeballs on all of them. So those are the ones to check out. Hello over in our YouTube chat to Dave Odessa and Biograph Abdelhagen and William Whitman. Welcome. Thanks for popping on over. This right here, that's the Discord chat. So if you're somewhere else and wondering where to go, you can head to adafruit.it/Discord. Look for the live broadcast chat channel that you see right there. Hello, Retired Wizard, Starman, Thin Man, Lit City DIY, Paul Cutler, hello. Thank you for popping in on the chat today. So we have a super cool product. I'm really excited about this one today. What I'll let you know is that you can go to that URL right there, and that QR code, and that will take you right to the product page where we have it on 50% off discount. There were a few in stock, and we had 100 stashed, so those are now all released into regular rotation, so you can buy them. You can buy up to 10 of these, and I can imagine some projects where that might be what you want. So go there and check it out, because this show is actually also broadcast from inside the product page, so you won't miss a thing. And as is customary on this show, before I say another word, I like to let Lady Ada talk about it from her new segment on Ask an Engineer, so please take it away, Lady Ada.
Start of the show, this one is really fun. So we saw these cool clear shaft potentiometers, and there's a little bit of a gap between the potentiometer and the PCB, and so I could fit a little NeoPixel inside of it. And so, in this demo, I just have a microcontroller reading the potentiometer analog read input and writing the NeoPixel output, and it looks like really awesome. The whole thing glows. And you could get a shaft that goes on it, a potentiometer knob that could go on it. But although it actually has more notches than a T18, I think. It looks like a T30 or something. But it also has this cute little little notchy thingy here to show you where it is. Honestly, I've actually seen this potentiometer used without a knob, just as is, using the little divots here as a grip. It's easy to use. We have two sets of pads and some header you can solder on. The potentiometer, you get the negative and positive and center. And then for the NeoPixel, you get ground, power, and input, and then on the other side, output. So you can chain these together. And if you are using this, as most people would, where you have the same power and ground potentiometer and LED, you can solder close the jumpers on the back, and that saves you 2 jumper wires. But this would be really cool. I'm designing a synth, and I'm maybe using this. I thought this would be a great little breakout for people who want like a little bit of glow. You want to have some feedback coming in through your potentiometer. So check out the NeoPot. That's the star of the show today.
Yes, indeed. Look, that's it right there. The product pick this week is the NeoPot. It is a clear shaft potentiometer with RGB NeoPixel LED mounted right underneath. And you can use this anytime you'd want to normally use a potentiometer. Stops at one end and usually gives you value of 0. Crank it up to the top, you get a value of 255 or 127, however you want to map it, depending on the ADC you're using. On things like the Feather RP2350 that I'm going to use for this, it's actually got a 12-bit resolution. In CircuitPython, we move everything into 16-bit, but then you can map that to whatever you want. And you've got the pads on there. I'm going to bring up this this helpful image here. So you've got solder pads on there. You can see I've already soldered the legs on there for the demo I'm going to show you. They are identical on top and bottom as you look at it this way, except for on the bottom we have a data in for NeoPixel, and on the top we have data out. So you can chain multiple of these together and just use a single pin on your microcontroller to control a whole bunch of NeoPixels. You can hook up, as you can see across the bottom there or on the side, you've got the 0 usually for the potentiometer and the 5 volt or 3 volt, so those are the P minus and P plus. In the middle you have the wiper there for the pot, so that's essentially an analog voltage divider that goes, and you can read that in your DAC to see where the dial is turned to. Then we have ground, which is meant for the NeoPixel. On the other side of that, VCC for the NeoPixel, could be 3 volt, 5 volt. And then you have the NeoPixel in, it says N-I-N there, not 9-inch nails. Up at the top, it's all the same except for you see N out for the NeoPixel out. So if you look on the bottom there, as Lady Ada said, and you'll see on mine, I'll show this in the overhead, it'll be a little clearer. I have gone ahead and soldered together those little jumpers so that we get the same pin for the ground on the NeoPixel and the low voltage on the pot. And then on the other side of that, we've got the V high voltage for the pot and the V in for the NeoPixel shared. So you save 2 wires. If you take a look at the down shooter here, switch to that. You'll see here I've got a little demo set up, and I'm actually going to add this to the demo. So let me unplug. This is actually just a breadboard that I designed a little cover for so that we could pretend like we're using a piece of electronics gear, commercial gear. Let me bring me up right there. So I'm just going to plug this in. You can see all of these have essentially identical wiring. They're using their own individual wire to the analog pins, so analog 0, 1, 2, and 3. They're sharing that yellow line, which is the data line for the NeoPixel, and then they each have a power and ground. So if I plug this in, you'll see these. Oh, they should light up. What's going on? Did I break something? Hope not. Let's see. Huh, I had this one upside down. I wonder if I just blew that one up. Good demo, good demo. Here we go. Yeah, whew, lucky. Yeah, so watch out, flipping those upside down. That could have some terrible consequences, but I survived it this time. So there you can see, I'm lighting up those NeoPixels based on their analog read. So if they're far left, we get this kind of amber. And as we go to the right, yellow, green, blue, purple, red. And if I put this case on, it's a little easier to see those. So in this demo, we can just set those values to twiddle those knobs. And then I've got some other code. Let me show you, let me switch to another view here. Oh, and before I forget, I'm going to bring up this little nifty thing, which is the little overlay. So we'll see if we get below a certain point, you'll start seeing real numbers. Right now we have over 100, so it just says in stock. And that is the sale price. So normally these are $495. Right now it's $248. Take that off for a second. So you can see here what I'm doing in code on these. It's essentially code for a NeoPixel and code for reading an analog potentiometer. So this is based on Foamy Guy. Tim wrote some code for the Learn Guide, which I'll show you in a second. It's based on that. I just extended it to work with these 4 potentiometers. So let me open up that code that I have saved right there. There we go, 4 NeoPot controller. So the way I'm running this, I'm using analog I/O to read the potentiometers, and I'm using NeoPixel, and then I'm also using Rainbow I/O for some convenient color on a hue saturation value wheel. So I set up 4 pins. Any one of these you want to use, you're just going to set up whichever pin it's plugged into, analog pin on your board, and then use analog I/O, analog in, board, and the name of that pin, so A0, 1, 2, and 3. And then I'm setting up NeoPixels on, in this case I just wanted to keep things running across the bottom of this feather, so there's a convenient one there called pin 24 that I can use to write out NeoPixel data. And I have that at fairly low brightness, which helps with the camera, but you can really crank that up if you want. And then this was based on a really neat bit of code that Tim had, using little buffers to take averages of every 10 reads of the potentiometer so that we're not flickering and reading slight changes in the analog reads, because those can wiggle around a little bit, be a little bit noisy. Then I'm using a little function for remapping things so that we can set that to within say 0 to 255 for NeoPixels, 0 to 127 if you're writing out MIDI, other. And here's how we're averaging things. So in the main loop, I go and grab a buffer of 10 reads of each pin, and then I set the pixels to be a remapped version of that. So we're taking the 16-bit values that provides and mapping them to 0 to 255, which is what NeoPixels use. Got another little piece of code here, which I just wanted to show it running more like a sequencer. So let me paste that in here. So you'll see, it's going to hiccup there for reasons of USB for a second. There we go. So now imagine that we're using a little MIDI sequencer, a little note sequencer or something like that. I'm running through, reading these. Actually, I'm pretending I have 8 of them, so you'll see it pauses for a second before it returns around. So these can be still adjusted to reflect the kind of levels or values. You could be adjusting brightness on these, and as the time marches along, it just blinks those black, just turning them off. So very similar code, except now I'm also dealing with this blink interval stuff. So that's a little live demo of what these look like in action. They're easy to use on a breadboard. Let me go to a bigger view of this for a second. So yeah, you can see these are nice and easy to use on a breadboard. The 2 sets of pins, you'll want to bridge the gap between the halves of your breadboard. Put these on a perma-proto board. One other nice thing, I'll just yank one unceremoniously. One nice thing that Lady Ada did on these, let me adjust this saturation on my camera, because that is looking very saturated. There we go, that's a little better. One really neat thing that Lady Ada did on these was include these 4 mounting holes on these, which we don't always do on such a small little breakout. But that means if you wanted to mount these to a front panel, so let's say you're building a synthesizer that has a panel, you could use some standoffs and mount those just to the front panel with those 4 holes, and then use wiring instead of header pins there to connect into your system. So really snazzy little guys. I'm going to switch over to the product page here, so you can see, like I said, this is 6387 is the product ID. They are normally $495. Right now you get them for $248. So this is the time to grab, let's say, 8 of them if you're building a little MIDI project. You tend to do sequence stuff in 8s. Get those at a nice price. And yeah, someone just posted in the chat. Some nice posted that they're using these. What's the product ID? 5676. These right here, clear micro potentiometer knobs, those will fit right on top of these. You'll still see the light shine through. You get a little extra diffusion on the sides. And they have a little set screw that uses a tiny Allen wrench or hex wrench to tighten them into the knob. So you can get a bigger, it's nice sometimes to have a little bit bigger knob to grab. If you look at the main guide here, there is a link to the primary guide. So from the product page, I should say, there's a link to the primary guide. That is that right there. Actually, Liz put that together. Thank you, Liz. So there's an overview here. Actually, let me go back to the overview for a moment because I wanted to mention a couple of these things. It's a 10K, 10,000 ohm linear potentiometer, so you're not going to use this for volume stuff. If it's analog, definitely if you're doing digital stuff with volume, you can write an algorithm to take this linear value and map the volume logarithmically. But these are not audio pots, these are linear pots. And they are actually Alps pots, similar to the Alps RK09, but instead of the usual black shaft, these have a clear shaft running through them. My wife mentioned that they look a lot like light bright pegs, which I agree. There's like a little bubble in there, which I don't know if that's a manufacturing defect or an intentional thing, but it's kind of how the lensing, I think, works on a light bright. So let's say it's intentional. There's a little bubble in there, helps lens that LED. I'm going to say, but it's a light pipe basically. It takes your light, shoots it out the end. And there's a view of it there. If we head to the pinouts, yes, pre-assembled, ready to go, so you don't need to solder that. That's how it comes, other than putting on those pins if you do or don't want those. It comes with some header pins, so you can put those on. But the main thing, the main board is all pre-assembled. You're not soldering a pot on there. You're not soldering a tiny NeoPixel. That's all done for you. And then there's a section on testing this out, getting this set up. That here's the code that Tim put together for doing an analog read and just changing the color on one of these. And then there's also Arduino code for that. In the downloads section, you'll see we've got the EagleCAD PCB file, which was really helpful for me putting together this case, because I was able to just lay that out in 3D and in Rhino and build my case around the proper spacing of these and proper dimension of these. So 3D models and the fritzing object as well, if you want to put these in fritzing to design your board. Let's see, what else? Oh, we're down. Okay, so yeah, I think we might have had 60 to start before the stock of 100 came in. So we are selling through these, as you can see from the little ticker below here. Thanks again to Tim and Scott for helping get this overlay work. This is actually a fruit jam that I'm using to overlay that stock information there. So let's see, any questions over in the chat? Let me bring this view over here and bring up the chat. Let's see. Yes, thanks so nice for the potentiometer. Todd said this was the place to score some NeoPot. Nice. Any questions in the YouTube? Batograph Abdul Hagen just mentions I spent a couple relaxing hours the other day reading up on gray encoding. I don't know what that is. I'll have to look into that. Relic says, these are so cool. Yeah, super cool. Oh, by the way, speaking of Relic, who's a synthesizer head, Lamore mentioned that we'd seen these in some synthesizers or related things. This is a really cool little sequencer from Korg, the SQ1, and it's got just single color LEDs in there, but you can see as the sequencer marches along, you get the little colored pots, which is helpful to know which step you're on. So that was, it's probably the identical pot, honestly. There aren't too many of these out there. So that's the one of the ones that we saw where Lamore then started the quest. That's taken quite a while. I feel like this is a many years in the making quest of finding the right source for what we needed for these. And now we've got them. So let's see, anything else? I think that is it. So I will, let me put this back in here. I'm going to very dangerously plug it in while everything's turned on, but this time have it oriented properly with, hey, look at that. Get in there. Oh, I should have plugged the battery in. That would have been cool. Has this battery got any juice? Let's find out. It does. All right. Just tuck that under there. Oh, did I put one of these out of place? No, that one's just moving. There we go. Okay, all of that just so that I can hold the thing up while we talk about it. But that right there is the product pick of the week this week. It is the NeoPot clear shaft potentiometer with RGB NeoPixel LED. Wow, wow. Wow, wow. Wow, wow. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week. See you next time. Bye-bye.